All right, so this video is going to cover example 3, parts A through C. Example 3 is taking us through this idea of converting a point in polar form to rectangular form, okay? So you can see here in this little description that rectangular coordinates are written in the form x comma y, right? That's not new news. We know this. But here we can define x to be r times cosine of theta and y to be r times sine of theta, where r and theta are the values from the corresponding polar coordinate. Okay, so in A, we are given that r is equal to -5. It's okay that this is negative. That just actually determines which direction we plot on the radial lines that we were dealing with before. We didn't do any examples in plotting those points, but I just want you to be confident in the fact that r can actually be negative. It just says we plot in a different direction away from the origin. Okay, so we have r is -5, and we have theta is equal to 3 pi over 4. And our goal is to get to the place where we can write a point x comma y. And all we're going to do is use the equations from this introduction that say x equals r times cosine of theta and y equals r times sine of theta. So we'll go ahead and set these up. We have that x is equal to r, which is -5, cosine of theta, which is 3 pi over 4. We know from our work with the unit circle that cosine of 3 pi over 4 is equal to -√2 over 2. So we have -5 times -√2 over 2. We have negative times negative, which will give us a positive. They give us a positive 5 √2 over 2. Okay, so that's our x component of our rectangular coordinate that corresponds with the polar coordinate -5, 3 pi over 4. So we'll do the same thing, except we'll utilize the other equation to find our y value of our rectangular point. So we have y equals r, which is -5, times sine of theta, and theta is 3 pi over 4. So from our unit circle, we know that sine of 3 pi over 4 is √2 over 2. So we're able to say that this is -5 times √2 over 2. This gives us a y value then of -5 √2 over 2. So what we've done is we have taken the points, the point -5, 3 pi over 4, we've taken that in polar, and we've converted it to the points, the rectangular points, 5 √2 over 2, comma, -5 √2 over 2. Okay, so this is the corresponding rectangular coordinate for the polar coordinate -5, 3 pi over 4. Oops, that doesn't look so good. I'll fix that. Okay, so again, this is our final answer, our rectangular coordinate corresponding with that polar coordinate. All right, example B. Example B tells us that our radius is equal to 3 and our theta value is equal to -5 pi over 3. So again, we're trying to get to a point where we can call this some point x comma y. And we're going to utilize those same equations that says x is equal to our radius, which is 3, times cosine of -5 pi over 3. We know from our work with the unit circle that the cosine of -5 pi over 3 is 1/2. So we can say that x is then equal to 3 times 1/2, which we can just call 3/2. We also know that we're told that y is equal to 3 sine of negative 5 pi over 3. And from our work with the unit circle, we know that sine of negative 5 pi over 3 is root 3 over 2. So this becomes 3 times root 3 over 2, which is just 3 root 3 over 2. So our rectangular coordinate is x, which is 3/2, comma y, which is 3 root 3 over 2. So that is the corresponding rectangular coordinate for the polar coordinate 3 comma negative 5 pi over 3. All right, last example for this video is part C. So part C, again, we have that idea of a negative radius, which is totally fine. We have the radius of -1 and a theta value of 180. So again, we're trying to get this to x comma y, utilizing those nice equations that tell us that x is equal to our radius times cosine of theta, which is 180, and the other equation y equals -1 times sine of 180. We know that cosine of 180 is -1, so our x-coordinate becomes -1 times -1, which equals +1, and we know that sine of 180 is 0, so y becomes -1 times 0, or just 0. So our xy coordinate is the point 1 comma 0. So 1 comma 0 is the rectangular coordinate that corresponds with the polar coordinate -1 comma 180 degrees. Okay, so your job at this point is to go ahead and try questions 1 through 4. Notice you're again converting each polar coordinate to a rectangular coordinate using the notes and also this video to help you. Make sure you check your work on the answer key when it's posted and let me know if you have any questions.